To demonstrate member functions, I'm going to return to the classes and objects demo from earlier demos with the person class and the tweeter class that inherits from person, but I've added some more capability to person since the last time you saw it. And let me just show you that. I'm going to open the include file, person.h, and you can see that I've added some functionality. Let's start with this one. Standard string get name. You can see that just like with the constructors, it's added in here in the public section. And if I right click, go to definition, you can see the code for get name. It returns the first name and then a space and then the last name. And I've actually changed the constructor and destructor to use this function. If you remember, person and tweeter have printouts in their constructor and destructor so that we can learn a little bit about the scope of objects that are constructed on the stack. Using this function, getName, instead of first name and then a space and then last name, means, first of all, our code is shorter. These statements used to have to span 2 lines in the file. Now they're just a single line. But it also gives us great consistency. If this was real application with real work to do, and someone said, wow, I hate that you print out first name space last name. It really should be last name, comma, space, first name. The old way, we would have had to go in and change it in a bunch of places and hope we caught them all. Now we can just go change the code for getName, and everybody's using getName. So this is one of the ways that encapsulating things up into functions can save you work. Refactoring is always a good plan. Code duplication, always a bad plan. Here inside person, we can just call the function just as its name, getName. No, it's, of course, the person getName, and it's for the particular person we're working on. So when we're constructing P1 and we call getName, it's going to use the member variables, the first, last, and arbitrary number of the P1 person. You can also just take an instance of a class, an object, and tell it you want to use one of its functions. And that's what happens in the main here. We can call p1.getName, and that's how we call the function. I have some other functions in person.h that are implemented a little differently. These are almost like properties. C++ doesn't support properties, but you're welcome to write functions whose names start with get or set according to the capitalization strategy that your team is providing. I'm using capital letters throughout rather than camel casing. It's your call. And these two functions, getNumber and setNumber, are inline functions. That's what we call it when the code for them is right here in the header file and nowhere to be found in the implementation file. So you scroll around in here, there's no person : getNumber or person : setNumber. They're implemented here in the header file. Implementing in the header file, if you find old enough material, they'll tell you, oh, that makes it faster. Being an inline function makes it faster, and the compiler decides whether something is an inline function or not, and can inline really short functions even if they're in the CPP file. However, putting them in here makes it obvious to anyone who reads your code, and remember, everybody has to be able to read your header, exactly what these two functions do. In the case of something like a property, which is really completely transparent, there's no validation, there's no business rules, nothing, you're fine with everybody knowing it. In the case of a real function that does real work, you wouldn't want it in the header file being compiled over and over again into every file that included it. It's fine for something like getNumber and setNumber. Now notice you can't tell when people are using the functions how they're implemented. Here I have a call to getName and getNumber right after each other, and there's no visible difference between them, and nor should there be. The point is that person has a getName function and it has a getNumber function. Neither one of them take any parameters. Fine. So getName returns a string. You can see that here. And getNumber returns an integer. You can see that here. And don't forget that Visual Studio will tell you that. So if I hover, it says standard string person : getName and int person : getNumber. Here I'm also calling setNumber. Let me show you setNumber. It's also inline, and I wanted to show you the return type, which is void. Constructors and destructors don't have a return type. There's nothing before their name. Every other kind of function, every free function, and every member function that's not a constructor or a destructor has a return type. But if it's sort of subroutine-ish and doesn't have anything to return, we say that it returns void. Void's not technically a type, it's a keyword that belongs where types go to say, I'm not an idiot, I didn't forget, I want to say nothing, an absence of information. Some people type void inside the round brackets when they're declaring a function that doesn't take any parameters. You don't need to, so I don't, but if you see it there, that's what they're doing. So set number takes an integer number and doesn't return anything. And here we're calling it to change the value of arbitrary number for this person P1. And then I'm immediately going to call getName and getNumber again so that I can see that I successfully changed the value from 123 that we constructed it at to 124. So this demo shows you calling a member function from within another member function. When you don't have any decoration, you just say the name of the function you want to call, and calling a member function on an instance of the class using this dot notation. So let's see it all happen. We still have the same code in the constructor as before, and one of the things that this shows you, remember that someone else is a tweeter, which inherits from person. And here, when it says constructing someone else, before constructing the tweeter object, it constructs a person object, and it can still use getName because getName is a person function, and that works out just fine. Anyway, then our tweeter goes out of scope, and we're down here where it says P1, and we call name and number. I'm set to 123. Then we use set number, and it comes out 124. And then finally, P1 goes out of scope and is destructed. All of the rules that you just learned for free functions about taking your parameters by reference or by value, about returning things by reference or by value, still apply to member functions. What I find very common with member functions is that they perhaps don't take any parameters because they work entirely on member variables of the class, or that they don't return a value because they keep their answer in a member variable of the class. That's what you see with getNumber and setNumber. It doesn't need to take any parameters because it can use the member variable arbitrary number, and it doesn't need to return anything when you set number because it's keeping the result in arbitrary number, which is this member variable of our class. And that pattern's really common in member functions. Also, member functions can be inline, as you see here, and that improves readability. And like all inlining, whether it's triggered by this or by some of the other ways you can inline, including the compiler just choosing to, it also improves performance. C++ is all about performance, and calling a function has a little bit of overhead in it. Inlining is something the compiler does to take that overhead away.